And next up, I'm going to try and play a video because the Brian has Brian Linuxine. I'm kind of wondering if he's picked the last name, if the last name Linuxine is real, or if it's because he's something he put there because of his Linux presentation. But either way, I'm going to try and get his video going and share it out to everyone.
I can preempt it if you want.
What was that?
Can you all hear me? I can preempt it if you want. The reason is very simple. I have an Irish surname and no one can pronounce it over here. It's a funny thing about England and Ireland. They, don't really sort of always gel together. Now you can see my avatar from 2 months ago. You get to actually see the full Monty now as I look like Rip Van Winkle. There we are. Avatar, Rip Van Winkle. Avatar, Rip Van Winkle. Yes, so part of the reason is I've given Chris, I obviously do a lot of Linux and we're going to keep this really brief. I've condensed the presentation into a streaming video because it's easier for everyone, less prone to mistakes and everything. And I'm on rather slow internet, so it never works anyway. So Chris is going to stream it now in a moment. He's really going to be very clever at this, and it's going to be seamless. And then I'm going to hang around for the questions if there are any.
Perfect. It'll start streaming in a moment.
Good.
A very good evening to everyone on the West Coast of America.
There we are, you see. So I'm going to shut up.
Share screen. Where is my screen 2? Advanced. Window. I'm just going to put that over to screen 1. Well,
so while Chris is getting that ready, I'll tell you a fun story about Brian. We actually met, I believe it was last year at OWASP London at an event where I was giving a talk as well as several others. And we ended up chit-chatting so much that during someone's presentation, people were like, shh, shh. But we had so much fun talking about all sorts of things, technology related. And he also runs this great technology group out in the UK and is also active in both OWASP London and hangs around with the Ladies of London Hacking Society. So if you've never heard of LLHS, I highly recommend you look it up. Even though it's Ladies of London Hacking Society, both genders and beyond both genders are more than welcome to join the group. So Brian's a great guy.
Thank you, Chris. And thank you for inviting me to a conference that starts at 2 in the morning on the West Coast of America. So when I get the invite, I think, oh yeah, she's in the Netherlands. It's going to be easy. It's a piece of cake. Yeah, I'm an insomniac and I'm a zombie already, which is why you've got the thing. So.
Well, I'm ready to hit play.
You're ready? I'm going to shut up. Go for it.
A very good evening to everyone on the west coast of America. And a very good morning to everyone here in London. It's an ungodly hour, and a very good afternoon and good day to everyone else around the world. I'm Brian Byrne. I'm going to be looking in at how to harden Linux systems with Linus.
Do forgive me if I
Get slightly tongue-tied. It's very early here. I haven't had enough caffeine, and it's going to be a very amusing morning. First off, big thank you to PajamaCon for inviting me to give this new talk. There are 2 technical demos, and everything is going to be seat of the pants. A big thank you to Tuxedo Computing for supporting our Linux community in Britain. I heartily recommend their laptops. They're lovely. They're Linux straight out of the box and no aggravation. All of these slides and all of my previous slides are obviously on SpeakerDeck. Brian Linuxing. I'm Brian Linuxing on SpeakerDeck, GitLab, GitHub, Gmail and Twitter. If you want to discuss Linux, got a minor problem, talk to me on Twitter. If you want to talk business, drop me an email. Obviously, I've been doing Linux since the time when Bill Gates had hair and Richard Nixon was in the White House. I started coding when I was a child, did BASIC, and then in the late 70s started professionally to do Fortran, COBOL, Algol, and I think about 14 languages in total. I've worked my way up across the whole field of IT, from operations, tech support, networking, technical management, project management, IT management, building small systems, large systems, greenfield sites, the lot. I've worked in finance, all the complex places you'd want to go, all the difficult places, all the tricky bits when there wasn't Google to consult, there was no Stack Overflow, and you just had to get on with it and know your onions. In 2016, I founded Linuxing in London, which has turned into the largest free and inclusive Linux group in Britain with over 2,900 members. Also, I've co-organised Covent Garden Pi Jam and the wonderful All London Raspberry Pi Jam, which are mini science festivals for kids, parents and carers. I love doing community events. If you want to get onto Google, you can see photos of those. We did a marvellous one earlier on, I think late last year, at the Microsoft Reactor in London. There's some brilliant photos of kids and their parents picking up tech and enjoying it. It's something I really enjoy. Obviously, I'm a freelance IT manager. I can organise your IT systems if you pay me, but let's crack on with the presentation. I've done operating systems since I was a youngster, 24 plus, I forget exactly the number. This is a wide selection from big systems to small systems. I've done more Windows than I have hair, and now I tend to prefer Linux because it's comparatively trouble-free, less aggravation. I started doing Linux in 93, Windows in 84. I can bore you for hours on Windows, Linux, whatever you'd like. I can sort systems out, but I really like doing outreach on Linux and teaching people how easy it is and how productive it is. Linux is everywhere now. On your Android phone, in the world's biggest supercomputers. If you have $200 million and you build a supercomputer, Linux is going to be the only choice of operating system that you'll pick. And why? Because it works. Microsoft run it, Facebook run it. When you run a film on Netflix, it's running Linux. But more importantly with Linux, you've got choice, you've got variety. You're not just stuck with one operating system that's a bit cranky, that wants you to work a certain way. DistroWatch lists 274 live Linux distributions as of this month. So if you want, you can play with many of these different types. They're clustered in family types. Some of them are very similar. If you learn skills on one particular version of Linux, it'll hold you in good stead on the others. But if you don't particularly like a particular distribution, the arrangement of the icons, the graphics don't support you, or support applications that you want, you can change, you can have variety. Again, Linux has plenty of choice and it's fast. This evening's topic, we're going to look at the topic of hardening Linux, what obstacles can exist, how to preempt them, then we'll crack on with 2 technical demos. Let's consider a dilemma. Imagine hypothetically you are charged with the security of a very large production system. It could comprise one machine, it could comprise 100, 200, you don't know. You've been told you've got to secure it, but no one can tell you how secure it is already. You've got to be careful when you touch it. If you touch it, do you break it? If you break it, does that affect production? There's lots and lots of issues when it comes to production systems in computing. They could be running here, as in this supercomputer of old, nuclear simulations. They could be running websites. They could be running revenue for charities. Production systems are the key systems in IT. They're the ones with the most uptime. They're the ones which should be caressed, looked after, and secured. But it's tricky. We've got to consider how and what type of IT systems work to understand that question in the first instance. So, you've decided you're going to develop a production system. For the sake of argument, it's a banking system. You have a development cluster. It comprises 100 nodes. You employ dozens and dozens of programmers. They develop the code. They need compilers. They need utilities. They simulate what they can. They then pass it on to a QA cluster. That cluster then simulates the transactions as they would find in a production environment, but they're only simulated. Much stricter than the development environment, but still not a whole production environment. You then run to a banking production system. There's no compilers, no extra utilities. It's locked down. You want nothing extra on that system that could cause a breach, help a breach, or help anyone gain access to it. So in practice, there's different levels of accessibility, usability in the type of systems that we encounter in computing. So, back to where we are. You have to audit all of these machines. How do you do it? Manually? That's what we used to do in the 90s. And it was a tedious process. We would have a checklist, we would have a mental picture of how a good system worked, and we would work through that now. Weeks and weeks would pass. Eventually we would produce a report. It may be completely accurate. It might have missed stuff. Humans are very fallible. When you're dealing with hundreds and hundreds of systems, it's very easy to make a mistake. And so now we want to go towards automated tools. That's your predicament. You're on your own. What do? You need to audit a production machine, And by auditing it, you're going to find problems. You're going to then suggest how those problems can be fixed. And over the passage of time, when they're implemented, your Linux system will become harder and harder to crack. But it's very difficult to know where to start. You need an ally. And your ally in this case is Linus. Linus is one of many Linux security tools. A lot of them are proprietary, a lot of them are closed source, a lot of them are incredibly expensive. They may work, they may not work in your environment. They might take an hour to set up, they might take 2 days. You don't know. Linus has the benefit of being quick, open source, and accessible. You can get it working very quickly, you can audit a system very quickly, you get the feedback, you then know what you can do to harden that machine. But the question is, why do we want to harden Linux? Isn't it secure? Ironically, Linux is used by the FBI. The Chinese state has mandated it. The NSA, major security organizations use it. And it is secure by design and by separation of privilege. Users can't, in general, damage a Linux system, but misconfiguration is a problem. Back to where we were. You're a developer. You have to get some code into the production system. You may cut corners. You may be pushed for deadlines. You may just make a mistake. You may misconfigure something that works on the development machine and then gets pushed over to the production machine. It's very easy for that to happen, and it has happened. So we want to look out for misconfiguration, and Linus will help us do that. We're going to do 2 technical demonstrations. It's very easy to do and get Linus installed. We're going to do it on a standard Ubuntu 2004 system, and then on a lovely Jetson Xavier NX from NVIDIA, which is effectively running a derivative of Ubuntu 1804. The only requirement in this instance to get going is to have Git installed on the machine. There are other ways of installing it, but this shows how quickly you can do this. It's very trouble-free, it's very easy, and as you'll see there, it's 4 lines. We're going to run it from a standard Linux account, not a privileged account, not one with root privilege, and there's a reason for that. We want to run a very short and accessible report. The root version of it is extremely thorough, but it does take a bit of time. So if we read down what we're going to do, we're going to git clone it, we're going to drop into the directory, then we're going to check the version we're running. Typically it can come installed on a Linux system from the supplier or OEM, or in this case Canonical's repos. The difficulty is the versions they have can be slightly out of date. The one we're going to be using is the most up-to-date version. It has all the goodies, and Michael, the author of it, assures me that there's been a year's work put into it to improve it, make it very user-friendly, make it very intuitive, and that's the one we're going to recommend. So now we're going to crack on and do the technical demos. Firstly, we SSH to a small Jetson Nano, Now if we look at the third line, we can see it's running on the ARM architecture, and it looks like a plain Linux system. Let's double check it. So we're running 1804.4. And you can see we're running it on an ARM processor. What a wonderful thing. Let's grab that. And now we're going to install takes a few seconds really.
Hold it down. It's going off.
Set directory. Whoopsie daisy. We're executing it, making sure we execute it from that directory we're in. Check the version. Version is okay. It's version 3. And now we're going to audit the system. But what we're going to do, we could run it interactively. We can run it here interactively, or we can pipe it to a file. That's what I think we should do in this instance, because we can then step through the individual reports and look at them. Give it a sensible name. Now you can see the obvious error there. I should have put the time command in front of the /. In practice, this will take 2 minutes to come through, and then we can step through and look at all the details it gives us. A thing to bear in mind about Linus is that it runs on the biggest of systems. So if you were fortunate to manage a supercomputer, you can download it, install it, run it up, it will work there. Or if you have a Raspberry Pi and you want to check the configuration, you can do the same. Talking to Michael, he tells me that every audit is unique. So it will scan your machine, it won't run a lot of junk. It runs across a plethora of distributions, obviously from Ubuntu, Debian, CentOS, SUSE, Fedora, Red Hat, even FreeBSD. It runs across all of them, and it produces a very detailed report which you can then take to management, and this is the key part here. When you're auditing systems, you've got to have evidence to prove what you think is wrong. You just can't simply say X, Y, Z. You know, that's probably wrong. You could be right. You need strong evidence. You need authoritative evidence. This gives you this. So we do the audit. We take it back to management. We get the buy-in of management. We get the buy-in of the technical teams. There will be resistance. There's no denying that, because once you've got this report, it's going to tell you things are wrong. They may be wrong on purpose. They may be done in a particular way because that's how your application works. There may also be oversights. But remember, everything's not just technology, it's human interaction. So when you come back with a report, you want to convince people that this is sensible, this is doable, and the changes make the system secure and better for everyone. That's the way to harden your systems. And this is the way to examine them. So we're going to look at this report here. it tells us non-privileged mode. If we did a sudo before the execution, it would ask for a password, it would then run, and it would scan everything, and it would be immensely comprehensive. I recommend running the non-privileged mode initially just to get yourself a feel for the application. When I ran it on this machine yesterday, the non-privileged took 2 minutes, the privileged 30 minutes. Still very quick, and you can see it gives us information about the whole of the machine. It tells us the architecture, what's actually there, what isn't there, and we can go down ever so slightly. You're going to see it will tell you if it misses things. You can see there it tells you there's no audit tools. It tells you I've got promiscuous interfaces. If something is a potential problem, it tends to flag it up in red. Or as you saw there, it said weak. So you're going to take this report, you're going to sit down, you're going to analyze it, you're going to talk to all the staff locally, and you're going to say, these are issues, which ones can we tidy up? How can we make our system better? Now, as we go on, this is where it gets really interesting. Go down, look at the suggestions. The suggestions are lovely. The suggestions are informative. They tell us things that we don't know. We could spend a week, a day, a couple of fortnights, a couple of months auditing a single machine and not come up with this information. This is precious. This is just in the standard non-root mode. The root version of this will give you a cornucopia of information. You see? Absolutely lovely. That's what you want. It gives you advice levels on SSH, how to harden it. Absolutely brilliant. So that is on a Jetson Ubuntu installation of all things from scratch, not been changed around. So you can see that even on a new system, there are ways to improve things. So what we're going to do now, we're going to quickly go over to another Ubuntu system and install it over there and have a look. So we can see there we're running on an Intel 64-bit implementation. The latest wonderful released version of Ubuntu long-term support. There's nothing additional on this particular machine. It's a fairly old desktop, as you can see. It's a dual core, 64-bit, fairly slow, fairly usable. You see, I'd already done it once before. So let's go in now. And we're going to get rid of the past. Old version, it's very simple to get rid of. Do that. I recommend being a bit careful if you do these commands on your own. But it's beautiful because if you're on a production machine, you don't need to install much. It's a directory. You can have someone standing over your shoulder, you can install the software, run it, and then take off the report, then remove it. You know the system's then secure. Again, very quick, a couple of seconds to come down. And once it comes down, we're going to run it in the interactive mode. It's very simple, very easy. Version 3, as we can see. You're stuck here, you want to know what are the options, and there are plenty. Oops-a-daisy. There we are. So you can audit a system, audit a Docker file. There's lots and lots of show commands, lots of immense goodies. I thoroughly recommend working your way through them. In the short instance, we're going to just do the audit. Now, comparing the two systems as we ran, if I ran this in non-interactive mode and piped it to a file, it would take about a minute. The Jetson Xavier NX is about half the speed on this. Now, if you're running in AWS or a big cluster, it's going to be much, much faster. So we can see it's working through things, it's checking things as it goes on, warnings, what's there, what it doesn't find, what it likes, what it doesn't like. That's what you want to take away. That's what you're taking away. You're taking away the condensed information of how to harden your Linux system. You're then going to use that in your organization to win the management over. You're then going to use it to sell to the technical teams that it will make their life easier. Less aggravation. Systems that tend to be secure tend to have less crashes. But it's a struggle. There's no denying that. It's a struggle, but you need hard evidence. You can't simply say the system's insecure. You need something to back you up, and this is the perfect tool for that. As I said, it's open source, it's free, and if we skip back here ever so slightly, we can see it gives us lots and lots of lovely suggestions as to how to increase the security on this system. That's how you harden a Linux system. You audit them, you use tools, you make sure you've got buy-in from people, and you do the changes very slowly, very methodically. And after a period of time, your Linux systems are wonderful, if they're not already. So, back to the slides. That's where we are. That's how you do it. It's very simple, not complicated. Collate the reports. Look for something serious. Hopefully you had the management buy-in beforehand, but even if you hadn't, you use the report to do that. You should tell them that insecure systems lose money. Millions and millions of pounds are lost by companies when they're breached. Techies will be a bit resistant. There'll be a lot of changes. So you want to do small wins. You want to buy in the senior technical staff. You want to do things very slowly, very methodically. You want to do things which, if implemented and there's a problem, you can roll back. You've got to look out for gotchas. Don't assume a change is naturally going to work. After a change has been implemented, been bedded down, audit again. Look to tidy up. Try to get metrics on how you're doing. And also, hardening of Linux is not just technology, it's people. And if you suggest changes, they may feel stressed. So you've got to win them over and say, aren't they going to be more stressed if the systems they've been working on are broken into? The tool that you're using is one of the best in the world. It's won numerous prizes. It's open source. You can look at it. You can view the source code. You can work out how it works. You can talk to the author on Twitter. He's very accessible. You can grab hold of a system and improve it. And I recommend you do this. These are the lovely links. If you want more nice tools, do pop over to OWASP. I really like OWASP London if you're this side of the pond. And yeah, I'd like to thank you for enjoying the talk if you have. And please leave a nice comment on Twitter. Thank you very much, and a very good night to you.
I'm very happy to take questions. I'm still awake. I sound awful. Sounds as if I've got a rat in my throat. Fire away.
So, anyone who has questions, please let Brian know. You're welcome to unmute yourself and ask your questions.